Okay, so last time we talked about a way to prove triangles similar, a shortcut using angle-angle similarity. Today we'll look at two other shortcuts that we can use to prove triangles similar. Talk about SSS and SAS similarity. Hopefully you can guess what those stand for. So the first one, SSS similarity. If you didn't guess yet, it stands for side, side, side. So if the corresponding side lengths of two triangles are proportional, then the triangles are similar. Remember, in order for something to be similar, the sides need to be proportional and the angles need to be congruent. So when the sides are proportional, the angles end up being congruent as well. So if all three sides have corresponding ratio, then the triangles are similar. So take the time, let's take a look at example 1 here. Tell if a triangle DEF or a triangle GHJ is similar to triangle ABC. So see if you can match up the corresponding sides and see if those triangles are similar. Restart the video when you're ready to check. So as we match up corresponding sides from triangle ABC to the sides from triangle DEF, we see that AB matches with DE 8:6, which is a 4/3 ratio. BC to EF 12:9, which is also a 4/3 ratio when we simplify it. And then AC to DF is 16/12. Divide those both by 4, you get 4/3. So those are all common ratio. So triangle ABC is similar to triangle DEF by side, side, side similarity. When we compare ABC to GHJ, we see that AB and HG are 1:1 ratio. AC and JG are also 1:1 ratio, but BC and HJ are 6:5 ratio when we simplify those down. So we would say that ABC is not similar to triangle GHJ. So now if we know triangles are similar, ABC is similar to triangle DEF, how can we solve to find the value of x that makes this true? So we need to make a proportion. So AB matches up with corresponding side is DE. So 4:12 as we match up the side from ABC to a side from DEF. Now if I want to find x, I see that x is either of these sides. So let's say we go BC. BC will match up with EF. So that's going to be the same ratio as x minus 1 to 18. Okay, so once we have this set up, we could also use this proportion 8:3 times quantity x plus 1. But since x will be the same, it doesn't matter which one we use. So I'm just going to take a look at which one's going to be easier to work with. And where I have less variables, I'm just going to use this proportion right here. So if I use cross products, 4 times 18 is 72. And 12 times the quantity x minus 1 is 12x minus 12. And then if I add 12 to both sides, I get 84 equals 12x. And then divide both sides by 12. X will be 7. And we can double check, see if that works out. 7 minus 1 is 6. Well, 6 out of 18 is 1/3. 4 out of 12 is 1/3. Let's compare it with this one also. 7 plus 1 is 8, times 3 is 24, so 8 to 24 is also a 1/3 ratio. So you just got to match up the corresponding sides and set up your proportion. The other similarity theorem that we'll take a look at is side angle side. So if one angle of a triangle is congruent to the angle of a second triangle, the lengths of the sides, including these angles, are proportional and the triangles are similar. So same as we did with side angle side congruence. So we're looking for two sides being proportional. So ZX and PM, they're not congruent necessarily. So ZX and PM have the same proportion, or same ratio, rather, as XY to MN. So notice just like with our Triangle congruence, side angle side, we're looking at the angle, included angle between those two sides. So we have two proportional sides and a congruent angle. If we have that information, we can prove triangles are similar. So taking a look there, you're building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left end using the angle measure and lengths shown? Because obviously you don't want it to tip over, so we want similar triangles in our lean-to. So we have 53 degrees. Those angles are congruent, so I need two sides that are proportional. So 6 to 9 is the same ratio as 10 to 15. So 6/9, divide those both by 3, we get 2/3. 10 and 15, we can divide both by 5 to also get 2/3. So since the two sides are proportional and the included angle is congruent by side angle side similarity, we know that these triangles are similar. All right, so finally let's take a look at comparing methods and figuring out which method we can use if we want to prove triangles similar. So take a look at these three examples here. Determine if you can show that the triangles are similar and by which method. Restart the video when you're ready. Okay, so I can prove triangle ABC is similar to triangle DEC. I can match up corresponding sides. So AC is proportional to DC, 18 to 30, which simplifies as 3/5. And BC is proportional to EC, 9 to 15, which also simplifies as 3/5. So I have two sides proportional, and the included angle is congruent by vertical angles are congruent. So triangle ABC would be similar to triangle DEC. Example number 3 below, triangle SRT is similar to triangle PNQ by side angle side similarity. As I compare SR to RT, it's 24. Or rather SR to PN, 24 to 18, simplifies as 4/3. And RT to NQ is 28 to 21, which also simplifies as 4/3. So I have two sides proportional, and the included angle is both 90 degrees, so side angle side. If I wanted, I could show it by side, side, side by using Pythagorean theorem to find this length of this third side and compare those. Number 4, I can prove triangle XZW is similar to triangle YZX by side, 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 or side angle side. Notice I have a right angle in both triangles, so I just need to prove two sides proportional. So it would be the set of the two smaller sides, the two legs of the right triangles. Or I could prove all three sides are proportional. I've shown that here with my three ratios. And if you're having trouble figuring out which sides match up, I can see the triangle W or XZW rotates and then dilates reduction to match up with triangle YZX. If I can't figure that out, just pick the side lengths. 20 is the longest side. Find the longest side in the other triangle. Then take the middle side, match that one up to the middle side, and then the short sides for each one. I see all the ratios are 4 to 3, so by side, 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 or side angle side similarity, triangles are similar. So today we learned two different shortcuts, the side angle side similarity theorem and the side side similarity theorem. And we found that we don't need to prove all parts if we can just find three sides proportional or two sides proportional and the included angle congruent. Do some practice work with that. If you have any questions, let me know in class.